Hello, Mr. Routh here. Here is a lesson on simplifying radicals. And let's get started. All right, back in the past couple of years, you guys have been doing things with factor trees, I'm sure. So when you do a factor tree, you take a number like 120 here, you break it into a couple numbers. So if you do 12, the other number is going to be 12 into 120, which is 10. And then you can break these numbers down further. 12 breaks into 6 and 2. 10 breaks into 5 and 2. And look, the 6 over here also gets broken down further into 3 and 2. So if you break 120 down as much as possible, you end up with 3 and 2 and 2 and 5 and 2. We're going to be using factor trees and other similar methods when we do the simplification of radicals. So what we find out is we end up with 3 2s, a 3, and a 5. Now, one interesting thing about factor trees is it doesn't really matter which way you factor. In other words, if I take the 120 and instead of breaking it into 12 and 10, I break it into 30 and 4, I'm still going to end up in the same place. The 30 breaks into 10 and 3. I can still break down the 4 into 2 and 2. And the 10 also breaks down into 5 and 2. Okay, so when I look at my examples here, I get 3 2s again. I have 1 3 and 1 5. It's the same as the last slide. All right, so 360. Let's look at how this breaks down. Let's break it into 60 and 6. And really, I can break it into any form I want because I know that I'm going to end up in the same place no matter how I break it down. The 60 breaks into 10 and 6. Now, for the lesson we're doing today, once we get 2 of the same number, we want to stop. So here, I've got 2 6s. So even though I could break those down further into 3 and 2, I don't want to for simplifying radicals, and we'll explain why in a little bit. So I just stop right there with the 6s. Now the 10 can be broken down further, and there's only one 10 on the board, so I'm going to break that down further into 5 and 2. So this, for purposes of today, this breaks down into 2 6s, a 5, and a 2. All right, so here's the first real problem. We've got the square root of 81 up on the board. Now most of you know that the square root of 81 is 9. But let's look at how to really do this using a method, because when we get to more difficult problems, we're going to want to use a method instead of just having to know it off the top of our heads. So 81 breaks down into what? Well, one factorization of 81 is 9 times 9. Now, like I said, once we get to two numbers that are the same, we want to stop. Even though I could keep breaking down the 9s into 3 times 3 and 3 times 3, I'm not going to do that. I'm going to hold right at 9 times 9. So, what happens? The 9 times 9 is underneath the radical sign. Now, here's the key step, and here's the key way to think about this. In order to get out of the radical sign, I sometimes liken it to a jail. In order to escape the jail, one of the 9s has to sacrifice himself and die. It's like, one guy has to create a diversion for the prison guard so the other guy can escape. So the 9 creates the diversion, he dies, the other 9 escapes from jail, and your answer is just 9. So here, radical 81 turns into just a simple old 9. Let's take a slightly more complicated example. Here's 400. What's the factorization of 400? Well, if I'm looking for two numbers that are the same, I might notice that 400 breaks into 20 times 20. Once I have two numbers that are the same, I stop. I don't break 20 down further into 10 and 2 or 5 and 4. I just stop. And so now I've got 20 times 20. They want to escape from jail. Number 20 digs a tunnel. He gets caught. The other 20 escapes. And radical 400 equals 20. Now, let's say I didn't realize that 400 equals 20 times 20. Let's say I thought it equaled 10 times 40. All right, well, let's say if I do that and I factor it down, and then I factor 40 and I say, oh, that's 4 times 10. Now I've got two 10s on the board, so I stop. But the 4 keeps going into 2 and 2. So then underneath my radical sign, I would write this. I would write the 2 and the 2 and the 10 and the 10. So I've got this. Then I realize, oh, well, one of the 10s can escape from jail, one of the 2s can escape from jail, and so a 10 escapes and a 2 escapes, and I've got 10 times 2. Well, what's 10 times 2? That's 20. So I end up at the same place as the last slide. Let's look at 360. Now, 360 was one of the numbers we did a factor tree for. And this was the factor tree we did. And remember, we stopped at the 6s because once I get two of the same thing on the board, I stop. So I can convert my 360 underneath the radical sign into 6 times 6 times 5 times 2. Now, the 5 doesn't have anybody to break it out of jail. The 2 doesn't have anybody to break it out of jail. They're both stuck. The 6, however, has another guy that he can use to break out of jail. So one of the 6 dies, he sacrifices himself. One of the 6s escapes from jail, while the 5 and 2 just sit lonely in their prison cell. So we get the 6 outside of jail, and the 5 and 2 still stuck inside of jail. Now, I don't like to leave this written as 5 times 2, so I multiply them back together, and I get my final answer. Radical 360 simplifies into 6 radical 10. All right, now some of you may have noticed that in order to factor these things, the key thing to look for are our square numbers. So if I want to factor 360 into something that's going to be the best number in order to simplify radicals, I'm looking for 4s, 9s, 16s, 25s, 36s. So for example, 360 equals 36 times 10, and 36 equals 6 times 6. That immediately gets me to something that I can break out of the radical sign. So these are the types of things you're looking for when you're simplifying radicals. Let's do one more example in this video. Here I'm going to start with a number already outside the radical, a 7, and I've got radical 75 underneath the radical sign. Excuse me, I've got a 75 underneath the radical sign. So I'm looking for one of my square numbers, and what do I see? Oh, well, 4 doesn't go into 75, neither does 9 nor 16, but 25 goes into 75, and it goes in 3 times. So I think to myself, oh, well, 75 is just 5 times 5 times 3. So I turn it into that. Now I've got 2 5s, 1 dies, so the other one can escape, and one of the 5s pops outside the radical, the other one dies. I'm left with a 3 inside, and the 7 is just still outside. They just carry down from line to line. Now, of course, I've got 7 times 5. I want to combine that. I don't like to leave it all messy like that. And when I combine it, I get a 35 radical 3. Okay, so this is the first part of the video. Check back for the second part, and you'll be able to do all the problems in level 1.